Okay, in applications, the last lesson in this topic, the same as we did before, mostly areas you're concerned about. So we're going to look at how to find areas between the curves and between the curve and the axis. So I just wanted to show you two examples pretty much and just draw your attention to how the questions are set. So this is find the area enclosed between the curves y equals sine x. So clearly red one is sine and the blue one is cosine. Between x is between 0 and pi over 4. So clearly you need to know that this is clearly pi over 2, right? Also not obvious from this picture, but it's pi over 2. How do I know? Well, because cosine is negative at pi over 2 and sine is maximum at pi over 2, so it must be pi over 2. And also I know that this is pi over 4. How do I know that? Oh, sine and cosine are equal at pi over 4. You should know the value. And so they want me to find the area between these curves when x is between 0 and pi over 4. So effectively, what I need is this area, this little sail here. That is very important to decide where you are. So, okay, so I want this area, and this area is going to be a blue line is on top, so cosine is on top. So it's a cosine x minus sine x. And suddenly it's not that difficult when you decided where you are, and you are integrating with respect to x between 0 and pi over 4. And derivative of cosine is sine, and negative sign here, and it differentiates to cos, and it's between 0 and pi over 4, and that is the answer. I've done the answer before, but if you want to do that, it's sine of pi over 4, which is 1 over root 2, plus cosine of pi over 4, which is 1 over root 2, minus 0. Sine at 0 is 0, and minus cosine at 0 is actually 1. And so you've got the answer. Okay, and now to compare this with the next example, just remember this answer. And just let's have a look at the next example. So our answer for this one was root 2 minus 1. So our answer was root 2 minus 1 for the previous one. And now they ask me to do the same, absolutely the same question. The only thing I changed here, that x is between 0 and pi over 2. We agreed that pi over 2 is here. Yes? So here. So I want the area between this enclosed, meaning between those two curves. And that area now is actually a different area. It's actually all this. That's area enclosed between the curves when x is between 0 and pi over 2. And so what I really need to do here, this is, remember our conversation about the point of interchange? What it meant, what I meant then and what I mean now is that here the curve which was on top changes. So up until pi over 4, sine curve, red graph, was on top. So I cannot do it in one integral. I have to go 0 to pi over 4, and my sine x is on top. And I have to add to this integral from pi over 4 to pi over 2 cosine x dx. And you can see that why I'm doing this, because the blue line is on top now. Okay, so I divided my area into 2 bits. One bit is this one. Okay, and now you can calculate your areas. So it's sine is negative cos x between 0 and pi over 4 plus sine x between pi over 4 and pi over 2. And I haven't done this, unfortunately, for me. So I have to do it now. So negative 1 over root 2 minus negative, so that's plus 1, plus sine of pi over 2. Sine of pi over 2 is 1 minus 1 over root 2. And so you've got 2 minus root 2. Very different answer to the one we had before. And all I've done here is changed one little limit. And I just wanted you to draw your attention to that. The limits are very important. You've got quite a lot of questions to do. They're all calculating areas. Just think how you set your integration correctly. That's all. Good luck.